Hello. I plan to do several videos about alkene reactions, so revisiting several reactions and giving you predicting products, and hopefully we'll do some synthesis. So in the first one, I'm gonna point out several reactions that are useful for you to know. So let's see, the first one, I'm gonna write a cyclohexane here, and I will put a metal. So one of the first reaction probably that you study in alkene reaction is hydrohalogenation. So if we put that with HBr, what's going to happen, that reaction goes Markovnikov. We have talked about that before. So the hydrogen pi electrons acting as a base, proton transfer, and you are going to form the more stable carbocation. That's the idea under Markovnikov mechanism. So in doing so, you add the H Markovnikov, you will add the regioselectivity is the H, is going to be added to the least substituted carbon in the double bond. This is it. So Markovnikov, and you will add the halide to the more substituted, because you're forming, after doing the H here, you're forming this carbocation, which is tertiary, and then you will have the attack by bromide. Here in the substrate, we gotta remember that the geometry of about this carbon is trigonoplanar, so the attack can come from above and below the plane. So say that I put something, I'm gonna make a put a constituent so that it's not identical on each side. So if I put a metal here, for example, and I put that on the wedge, then I can have the products will be different because I'll be creating a chiral center. So when you do that, then you're not touching this chiral center, but here, since you can have the attack from above and below the plane, you will have, for example, bromide and metal plus the other product. So here I was attacking from the top, so bromide ended up on the wedge, but you can also attack from below. You can have bromide here. So at the center, the configuration is inverted, but because we have another chiral center, the relationship between these two molecules is diastereomers. Okay, so that will be the Markovnikov path. Then we need to remember that this is when you use, you do hydrohalogenation in the absence of peroxide. If you do that and you do the same thing with peroxides, then the regiochemistry is the opposite. So in this condition, you will get the anti-Markovnikov product. Okay, and that will be then, you will add the H here and the bromine here. And so let's do that. Well, I forgot that I had added a metal, so I'm going to be consistent with that. So now my products, and let's use another color here. And if it is anti-Markovnikov, then you will add the H here and the bromine here. I'm not going to go over that mechanism, that is via radical. So, and I have a series of video about radicals. The point is that you add, when you add the bromine, you add it here because you create a more stable radical. I'm just going to draw the, say, the intermediate to that. So after the initiation step, you will form this radical. So, and that is, you're going to add bromine here, and you form that radical. That's your intermediate. And here again, the geometry is trigonoplanar, and you will add the H again with the opposite regiochemistry. So your product, this again, that's your intermediate, that radical. Your products is anti-Markovnikov. So you will have stereochemistry here is not changing. You will add the H here, and you can add it from either side of the plane. So you can have this product, and here it means that the H is on dash, and you will have the other product in which, here I'm missing something very important, which is the bromine. So if you did that, you will have, say that you, well, you have a number of products actually. You can have bromine like that. You can have it like that. And here, if you do that, you'll have that plus two more products in which this two will be dashes. So there is a number of products in the other pathway. Point is that I want you to remember then when you're studying these reactions that if you have just the hydrohalogenation without peroxide, regiochemistry is more cognical. So H here, bromide here, and you, because I created this chiral center, I put it here. These are not enantiomers. They would be if I didn't have the metal. Now they are diastereomers. In the radical pathway, when you use peroxides, then you add the H at the bromine first, and you form the more stable radical in creating this. There is a mixed product. We have two more here. But I don't have a room for that. In those, you would have this two, but this can be dashes. This will be dashes. Okay, I'm gonna do more of that. I'm just reviewing reactions using problems. See more in another video.